Hello students, welcome back. In this next lecture we'll be looking at the chemistry of life, and one of the things that we'll explore in this lecture will be the atoms that are found in living organisms, the elements. We'll also look at molecules that are found in living organisms and the macromolecules. And so this is part one of the chemistry of life. In order to explore the chemistry of life, there are a few terms that we need to define. And the first one I'm going to define using a scenario. In the 5th century BC, there was this Greek philosopher. His name was Democritus. And he came up with this scenario for us. He stated that if we started out with a nugget of gold, okay, so here we're going to have here our nugget of gold. Don't really know how to draw a nugget of gold. If it's okay, I'm going to actually draw like a square, just so to make it easier. I'm sure somewhere in the world there's a nugget of gold that looks like a square. Okay. Here's our nugget of gold. Let's go ahead. Yeah, we can go ahead and put here gold at the bottom. So this is our nugget of gold. Now he stated that if you had a nugget of gold, that you could divide this nugget of gold. You could chop this nugget of gold in half, and then you would have a smaller nugget of gold. And then he said you could actually divide it in half again, and you could have a smaller chunk of gold, and then you could divide it in half again and have an even smaller chunk of gold, and then you could divide it in half again and have a smaller chunk of gold. And he said that you could continue to do this until you got to a point that if you cut that gold nugget one more time, it would cease to be gold. It wouldn't be gold anymore. And he said, so that's the last indivisible piece of gold. And so he stated that the smallest indivisible portion of a piece of matter that would still be gold in this case, that is called an atom. That is an atom. And so an atom is the smallest indivisible piece of matter. The smallest and indivisible. That's key. You can't divide it anymore. You can still divide it, but if you divide it again, it's no longer gold. So the smallest indivisible portion of matter. And so this is the first definition that we'll need to have a grasp of. And the person who came up with this concept, he was a Greek philosopher. His name was Democritus. And he did this around the 5th century BC, so about 2,500 years ago. And so around 500 BC. And so that is an atom, the smallest indivisible portion of matter. On this slide, let us look at an atom. An atom. I'm going to zoom in here. Just choose a representative carbon to atom to talk about, and we'll let it be carbon. I don't know how I want to do this here. I'm trying to decide. Okay. In an atom has three components. An atom has particles. Well, first I just need to define an atom. Okay. An atom has a region right in its center, and we'll call this region the nucleus. And so this is going to be the nucleus of the atom here, and that's white. And around the nucleus there are going to be some energy levels, or orbits. You can call them orbits. And on those orbits we are going to have, okay, so here's an orbit here around the atom, and here is an orbit around the atom. Okay, within the atom, or within this center of the atom here, in this area, we have some subatomic particles. Some of them have positive charges, and we'll make those, what color starts with P? Pink. Some of them have, so we'll give them a 1, 2, 3, 4, 5, 6. And so we have 6 positively charged particles in this central area, and we have some neutrally charged particles in this area. We'll make them gray since they don't have any color. 2, 3, 4, 5, 6. Okay, so we're going to just zoom in here. Now for the pink particles, we said that they don't have any, we said they have a positive charge. So let's give them a positive charge. And the gray objects, they don't have any charge. Okay. Now, circling in these orbits that we have here, we have some particles that have a negative charge. Okay, and we have 2 of them on this level, and we have 4 on this level here. And these numbers can change. And so all of these particles have a negative charge. We're going to define these in just a moment. So these have a negative charge. In this structure, this is a representative structure of an atom, one atom. Okay, let us define these particles and these components of the atom. Okay. I'm going to zoom in here. Okay. The structures here that have a positive charge are called protons. the structures here which have no charge at all, these are called neutrons. And notice that they're both on the interior of the atom. And this structure here that has a negative charge, it is called an electron. Okay. Now the protons and the neutrons are in this white area, or this central area. And we call this entire central white area. I don't know how to point to it, so I'll just do it like this here. This white central area, this is called the nucleus of the atom. That is called the nucleus of the atom. And those are the components that you need to know for an atom. And this atom has a name because it has 6 protons. Because it has 6 protons, it is called carbon, because all carbon atoms have 6 protons. So it has 2 parts to its name, carbon. Carbon because it has 6 protons. And if we look back in the nucleus, let's count the particles in the nucleus. There are 6 protons and there are 6 neutrons. And so this specific atom is carbon 12. Carbon because it has 6 protons, 12 because it has 12 particles in the nucleus. And this is an atom. On this slide, we're going to look at different types of carbon atoms, because we need to, and we're going to use those different types of carbon atoms to define another term. Okay, let's make our central area. Okay, we're going to make these are going to be our nuclei. Now let's make our orbits. Okay, so we're going to make 3 carbon atoms. Let's start with this one here. Let's put each of these carbon atoms has to have 6 protons. So 1, 2, 3, 4, 5, 6 protons in the first one, 6 protons, 4, 5, 6 in the second one, and 6 protons, 4, 5, 6 in the third. So that makes it carbon. And so for the neutrons, 1, 2, 3, 4. For the electrons, 5, 6. 1, 2, 3, 4, 5, 6. All of these are still carbon. 1, 2. Well, they have to be carbon because they have 6. Because they have 6 protons. Now for the neutrons, and this is where things can differ. All of these are still carbon. We know it's carbon because it has 6 protons. Okay, let's do this. Okay, neutrons. For the first one, we're going to have 6 neutrons. Well, let's do this first. So all of these are carbon. Let's get something a little darker here. We know they're carbon because there are 6 protons. So that's carbon. This is carbon. And this is carbon. Okay. Now if we go here, we don't know what the number is because we don't know what the number of neutrons. So let's give this first one. Let's give the first one 6 neutrons. 1, 2, 3, 4, 5, 6. So that gives you 12 items in the nucleus. So this first carbon is going to be carbon 12. The second one, let's give this one, let's give it 7 neutrons. 1, 2, 3, 4, 5, 6, 7. This has 7 neutrons. And so this carbon is going to be carbon. It has 7 neutrons and 6 protons. So this carbon is carbon 13. And the last carbon, let's give it 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. And so it has 8 neutrons and 6 protons. So this carbon is going to be carbon 14. And so each of these is an atom of carbon. Carbon 12 is the most abundant, but each of these is still carbon. Each of these is an atom of carbon. So carbon 12 is an atom of carbon, carbon 13 is an atom of carbon, carbon 14 is an atom of carbon. And we can also say an atom is the same, has another word that's basically the same as it. The word is isotope. Carbon 12 is an isotope of carbon. Carbon 13 is an isotope of carbon. Carbon 14 is an isotope of carbon. And isotopes and atoms are the same, except they just differ in the number of neutrons. So each of these is an isotope. And so isotopes and atoms have the same number of protons, just different numbers of neutrons. So an isotope is the same thing as an atom. And so here we have all of the isotopes, or all of the atoms of carbon. Collectively, all the isotopes or atoms of a carbon are known as that is known as an element. So carbon is an element, and it's made up of only atoms or isotopes. There is no bonding that goes on here. So an element. So the element carbon has some carbon 12 in it, it has some carbon 13 in it, and it has carbon 14 in it. The most abundant isotope or atom is going to be carbon 12. So if someone is just talking about just carbon, so carbon is in this molecule, most of the time in that situation you're talking about. And so if someone just said, draw me and draw the element carbon, or show me the atomic structure of carbon, since carbon 12 is the most abundant, they would be talking about, you would draw them carbon 12 with 6 protons and 6 neutrons. So this is an element. An element includes all the isotopes or atoms of a particular chemical. Let's discuss another isotope, the isotopes rather of another element. Some isotopes are so common and used so pervasively that the individual isotopes are given their own names. Okay, and now let's make ourselves. This is going to be our nucleus here. Want to be here, just make it consistent. It's going to be our nucleus, and let's give ourselves our orbit here. Okay, now this, let's just go and do the same thing all the way across. Okay, now this atom has, just like before, we're going to show 3 isotopes. It has 1 proton all the way across. And it is going to have 1 electron all the way across. Now, because it has 1 proton, it becomes identified as a certain element. And so this is going to be hydrogen. Because all hydrogen atoms or isotopes have 1 proton. So these are all hydrogen, but we don't know the number. So this is hydrogen as well. So right now these are all identical atoms of hydrogen, or identical isotopes of hydrogen. Now let's start over. Well, no, let's start with the most common one. This hydrogen here, this first one here, this first isotope of hydrogen has 1 proton and 1 electron, and it has no neutron. And so because it has 1 proton, it's hydrogen. Because there's only 1 particle or subatomic particle in the nucleus, it becomes hydrogen 1. So this first one is hydrogen 1. The next particle here, or the next hydrogen, the next isotope, has 1 proton and 1 neutron. So it has 2 particles in the nucleus. And for that reason, we call this hydrogen 2. And the last hydrogen here, it has 1 proton and it has 2 neutrons. So it has 3 particles in the nucleus. And so for that reason, we call this one hydrogen 3. That's pretty straightforward, just as before. Now, all of these isotopes or atoms of hydrogen make up the element hydrogen. That make up the element hydrogen. So if you looked on the periodic table for hydrogen, you wouldn't, for its hydrogen 1 has an atomic mass of 1. Hydrogen 2 has an atomic mass of 2. Hydrogen 3 has an atomic mass of 3. But if you look on the periodic table, you see none of those numbers. You see the atomic mass of hydrogen is going to end up being 1.0008. And basically it's an average of all of the various isotopes. And since it's closest to 1, you know that hydrogen 1 is the most abundant of those 3. And that's why the atomic mass on the periodic table has a decimal number, because it's the average of all of the isotopes that are found. But that's not the point of this slide. The point of this slide is coming up now. These different isotopes of hydrogen are so important to chemistry that chemists have given them their own names. And we're going to define those now. Hydrogen 1, most of the time it's just called hydrogen. But to distinguish it from the others, chemists sometimes call it protium. So hydrogen 1 has its own name, protium. So protium is a particular isotope of hydrogen. Hydrogen 2 has its own name because there are 2. It's called deuterium. Deuterium for 2. Deuterium is the name of the alternate name for the hydrogen 2 isotope, or the hydrogen 2 atom. And hydrogen 3 has another name, its own name, tritium for 3. And so the whole point of this slide is to show you not just that there are different isotopes of elements, but that some elements or some isotopes or atoms are so important that chemists give them their own name. And this is the element hydrogen. Okay. There are 6 major elements in the human body. 6 major ones. And what we're going to do, we're going to identify those 6 major elements. We're going to show you the structure of each atom, of each of those, but we're only going to draw the isotope or the atom of the most common. We're going to draw the structure of the most common atom or the most common isotope. So let's do these in order. The most abundant element in the human body is oxygen. By weight is oxygen. Okay. So we have the nucleus there, and it has 2 energy levels. Okay. And let's just, from here on out, we will make protons. We'll make protons red. So it has 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. And it's going to have 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. And it will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And so this is oxygen. the most abundant element in the human body. So oxygen has 6 protons, and here we're showing 6 neutrons. Its percentage by weight is 65%. So oxygen makes up 65% of the human body. And this is oxygen. Next, we will look at the next most abundant element in the human body. Okay, there's its nucleus. And this will be familiar to us all. Okay, this element has 6 protons and 6 neutrons. So we know it's carbon, carbon 12. And of course, it has to have 6 electrons. And so this element, the second most abundant element in the human body, is carbon. And we won't put a number behind it because we aren't talking about an individual atom. We're just talking about the element in general. And it has 6 protons. And its percentage in the human body by weight is 18%. The second most abundant element in the human body is carbon, with 6 protons. The third most abundant element in the human body, again, is one that we've already seen. Okay, we'll draw it. Okay, this element has but 1 proton, no neutrons. Well, it can have neutrons, that doesn't matter, but this is the most abundant one. This is the most abundant atom or isotope, and so this element has to be hydrogen. So this is the element hydrogen. And again, we don't put a number behind it because we're not talking about an atom. We're talking about the element. And the element includes all of the atoms or all of the isotopes. And hydrogen has 1 proton, always 1 proton. And its percentage in the body is 10%. And so here we have hydrogen. The hydrogen element has 1 proton. It is the third most abundant element in the human body, with a concentration or with an amount of 10% of the body weight. And this is hydrogen, the element hydrogen. The next most abundant element in the human body is going to be nitrogen. Let's look at its atomic structure, the nucleus here, and let us next get our orbits. 1 and 2. Nitrogen has 7 protons. 1, 2, oops, spread these out a bit. 2, 3, 4, 5, 6, 7. too big. 1, 2, 3, 4, 5, 6, 7. 7 protons, and it is going to have 7 neutrons. 2, 3, 4, 5, 6, 7. And it is going to have 7 electrons. 1, 2, 3, 4, 5, 6, 7. And this element is nitrogen. And it is nitrogen because it has 7 protons. And its percentage in the human body is very low, only 3%. So the fourth most abundant element, or the fourth major element in the human body, is nitrogen. It has 7 protons, and its percentage is 3. And this is the element nitrogen. The next two major elements, we won't draw the atomic structure for those. They are calcium and phosphorus, and these are minerals. And so what we'll do here, we'll just identify the calcium. We'll just give the percentage of these. Calcium has a percentage of 1.5%. It's the 5th most abundant element in the human body. And then phosphorus. And phosphorus has a percentage of 1%. And these two elements, and the ones that follow, all the ones that follow, all of these are minerals. And minerals are going to be, how can I define them? Inorganic elements that plants extract from the soil. And we use these. That's how we eventually get calcium and phosphorus into our bodies. And so these are the 5th and the 6th most abundant elements in the human body: calcium and phosphorus. Okay, let's review the major elements of the human body. The most abundant, number 1, is oxygen with a percentage of 65. The second element is carbon with a percentage of 18. The third is hydrogen with a percentage of 10. The fourth is nitrogen with a percentage of 3. And the 5th and 6th are calcium with a percentage of 1.5 and phosphorus with a percentage of 1.0. And these two and all of the other elements in the body are minerals. And these are the major elements of the human body.